So first of all, I want to, most of you are relatively new to the company, and I want to introduce you what is our mission statement, because everything is going along with the mission statement. So our goal is to bring innovative control release encapsulation systems across personal care and pharmaceutical applications. This is the areas that we are working, pharmaceutical and personal care. We are much less involved in hard surface, industrial, and so on. And our aim is to make people's life better and change the world, one product innovation at a time. So this is the big picture. This is the big thing that we are looking forward. So the purpose of this specific one is at the end of this meeting, first of all, you will be able to identify and tell to yourself and other people, what are the characteristics? What is MultiSal? You will see it's not one creature. It's a platform of structures that have something in common. That's why they're calling MultiSal, and it's a registered name. So we own the name. Then we want you to see how to, after you know all about MultiSal, is how to choose which MultiSal would go to what product, and making the decision whether it's a MultiSal technology that you can use for this application or maybe something else. MultiSal is not a good fit for this application. And number three, I will introduce you through this 50 minutes, 4 different products based on MultiSal, and you can see the variety. So at least you will know what the 4 products are really doing. So this is the goal. And remember, at the end, 4 products you know, and you can talk about MultiSal. In order to understand well MultiSal, we have to take one step backwards to understand Sal sphere. So briefly, you remember the Sal sphere. Sal sphere is a structure and a solid core. And this is practically a nanosphere, but we never mentioned the word nano, because in the cosmetic business, nano is connected to something negative. So we have a solid structure, and we have a special shell. The structure, the core, is typically hydrophobic. It's made out of waxes, butters, esters, and so on. It's lipid. Why we make it lipid? Because in lipid, we can lock in materials, ingredients, and also lipids and fats are compatible with our skin. Our skin is also lipid, so therefore they can stick to our skin and slowly release. What's unique about the shell? It's typically hydrophilic. It's a polymer or polymeric surfactant structure, and this is the basic feature of Sal sphere. It's always considered to be suspension. This is the word, suspension. Suspension is different from emulsion. The major difference is suspension are suspending small particles. Compared to emulsion, it's not solid small particles. For example, milk is a suspension, because there are particles of lactose suspended in the water. They are small, so they look like it's homogeneous. But if you filter them, you know what you get cheese. So our Sal sphere is a suspension, and many people get confused, suspension, emulsion. So now you know what it is. Okay, so what's happening is we take Sal sphere technology and we re-encapsulate it into MultiSal. So what is MultiSal? Is encapsulated Sal sphere. So imagine we have an active ingredient. We first encapsulate it in Sal sphere. Then we take many Sal spheres and put them into one bigger particle, a particle that you can actually see without a scanning microscope. And it has a size of a powder, so about 40, 60 micron. And the Sal spheres are compacted inside the MultiSal. It could be one type of MultiSal, could be multiple MultiSals into one. So already you understand that the first product, Sal Sphere, is liquid. MultiSal is a powder. It resembles the double encapsulation, which means first time Sal Sphere, second time you see the wall that locks in the Sal Sphere. It's a free-flowing powder compared to Sal Sphere, which is a liquid. And the release is totally different from Sal Sphere. In order to release, the shell, the yellow fraction, has to break down. How does it break down? I tell you in a minute. But before I go tell you in a minute, I just want to let you know that the shell could be made of different ingredients. Could be made of natural polysaccharides like starches. Could be made of a stout that's been modified. Now, it could be modified chemically by a chemical reaction. It could be modified by an enzyme, and it could be modified just exposing to acid and breaking it down. So it could be the natural or natural modified, and then modified in a different way. And it could be synthetic. And we could do all of this, and this is, again, our patented technology. We are the only one with this product, and this is our MultiSal structure. Now, the major features that you need to know and understand. Number one, it gives a fantastic protection for the ingredients that we encapsulate. For example, perfume. You cannot smell when it's encapsulated, or the intensity of the smell is significantly lower. Menthol, you take MultiSal menthol, you don't smell the menthol until you break the wall. So it's a very good technology to encapsulate very volatile ingredients, number one. Number two is the release. The release is based on trigger. Something has to come and break the wall. We use typically water, so we say it's activated with your body moisture, but there could be other triggers that could activate the release. It could be heat, it could be other specific chemicals, it could be enzymes. Imagine enzymes that are in the skin, and it's a certain time, certain diseases, this enzyme, the level of this enzyme is elevated, and as a result, they can break the wall and release. So it gives stability because of the double wall, and also it gives the long-lasting benefit, and it's water-free. Why it's so important to mention water-free? Because many people don't like to use preservatives. Okay, there is bad press for preservative. So this is a product without preservative because it's dry. Dry product don't need a preservative. Now, this is a short video that I would like to show you here, if I can make it work. A short video. Okay, no. No. Okay, short video about what is happening.
Salvona Technologies presents MultiSal. In this video, we will introduce one of the three main delivery systems that Salvona Technologies has to offer, the MultiSal delivery system. The MultiSal technology is a unique double encapsulation system. The outer microsphere is about 30 microns in diameter, and within it are smaller spheres known as Sal spheres. The Sal spheres, approximately 0.1 to 0.3 microns in diameter, contain the active ingredients. The double encapsulation design of the MultiSal technology has several important benefits. The first benefit is that it provides enhanced stability through the extra protection of the active ingredients, which prevents the actives from reacting with other surrounding ingredients such as oxygen. The second benefit is the multi-step release profile of MultiSal, which extends the time that the actives are available on the skin. MultiSal appears in a free-flowing powder form, offering added benefits of ease of use. MultiSal allows ingredients that would otherwise only be usable in water-based mediums to be used in anhydrous or waterless applications, such as lip balms, deodorant sticks, soap bars, dry shampoos, and toothpastes. Additionally, while MultiSal is best used in anhydrous applications, it also has the potential to be formulated into some applications that have low water content. The active ingredients can be released from the MultiSal technology by one of two mechanisms. One, release through rubbing onto the skin, and two, release activated by the presence of water. Release activated by rubbing. Release of the active ingredients through rubbing is a special mechanism used for MultiSals that are stable in water, such as MultiSal Cool and MultiSal Retinol. The shell of the pressure-sensitive microspheres breaks down when the MultiSal is rubbed onto the skin. As a result of the rubbing, the microspheres deform and release the sal spheres within, which go on to release the active ingredients that they contain. A more in-depth explanation of the sal spheres' mechanisms of release can be found on the sal sphere video. Water-triggered release. MultiSal comes in a dry powder form that is stable until introduced to water. Upon contact with water, the sphere gradually absorbs the water and dissolves, activating the release of the submicron sal spheres inside. The sal spheres, in turn, break down and release the active ingredients. Salvona Technologies offers quality delivery systems that modify the way functional and active.
Okay, I hope you understand here what we wanted to show you, the structure and what can trigger the release. If you have any questions or comments, please use the chat. Remember, it's not a lecture. It's supposed to be a meeting and a discussion. And it's supposed to make you understand what is MultiSal, where and how to use it. So focus and see if you can really answer these questions as we go forward. I want to show you example number one, the complexity of MultiSal and the value. So this is called MultiSal Menthol. Menthol is available, mostly natural menthol or synthetic menthol, as solid sphere, not sphere, but rods like this. This is how menthol looks like in reality. So we are trying now to dissolve it. One menthol by itself is not soluble in water. So people just cannot put it in the formula as is. There has to be a mechanism of solubilizing it, and it takes a long time. And typically 30% of menthol will evaporate. Why? Because menthol is not so soluble. It's more of a material that undergoes immediate phase transition to volatile, to liquid. From liquid, it goes immediately to vapor. So that's why we smell menthol at very low concentration. We can smell because it's volatile, and our senses are very precise with materials that are gas or volatile. So what we do is this: we take the menthol first and incorporate it in sal sphere. This is the basic story. Menthol goes into the sal sphere. As I said, menthol is not soluble in water, but it's soluble in fat, in lipid. That's why the core, you see now the logic, why the core is lipid. Lipid helps to solubilize the menthol. Now they take the sal sphere and incorporate it in MultiSal. In this way, if you look into MultiSal, you will not be able to smell the menthol. So what does the shell do? The shell is protecting from premature release, and it has to be broken down in order to release the menthol. So there are different ways to release the menthol. Now, another very important feature of MultiSal, very important feature, is heat stability. And if you look at the lab in the back, there is a machine that's called DSC, TGA. DSC stands for differential scanning calorimeter. This is a system that exposing a sample to heat, okay, in a systematic way. At the same time, it's measuring what happens to the system as it's exposed to heat. So it simulates practically what happens when we produce it, because we produce heat to dry and to produce particles, but also some of the process using heat. For example, when we make a lip balm, we mold it, so we increase the temperature of the environment. And the question, will it survive? So look at the numbers by itself. This is the mass retained, okay? How much of the initial weight we keep as a function of temperature. So what do you see? If you use menthol and you start to heat it up from 25, you see at about 80 C, you lose the menthol and you lose it rapidly. By 120, you have no menthol in the sample. However, if you encapsulate it in MultiSal, you lose a few percent, but you get a straight high level of retention. This is the major benefit of MultiSal, heat stability. So every process that involves heat can benefit from this technology. So it is used, I'll show you a couple of processes in a minute, but this is another feature to remember about MultiSal, and this is the heat stability. So you can see, and from other data that we generated, it's stable up to 160 C, which is a cooking temperature practically. So you can cook it. So what happens when you cook it? The functional ingredients will be retained. The only thing in this case that will release them is water. So if the environment is dry, they will not release. So when you buy frozen pizza, for example, when the water in the frozen pizza or any kind of food, but let's say frozen pizza, the water is not active, it's solid, it will not activate MultiSal. But the moment you microwave it, the heat and the water will break down the MultiSal and you start to smell if the encapsulation is a flavor, okay? So this is how manufacturers are bringing back the flavor that lost during the process. MultiSal flavor or MultiSal fragrance for, let's say, a deodorant stick. Deodorant stick, some of the deodorant stick are totally anhydrous. There is no water, or there is a little bit of water, but the water is not available to break it down. So the only thing that can activate it is heat and water. Okay, so we have more data about water triggering. For example, you see here, this is the intensity of the fragrance or menthol that was encapsulated. You see dry, the intensity is very low. You spritz it with some water, puff, you get a high intensity of the menthol. So menthol, MultiSal menthol is activated by water. So to summarize here, MultiSal is a powder. It's a free-flowing 20 to 60 micron, and the shell can dissolve or swell. This is very important. Depends on what material we use, we can control the mechanism of release. What does it mean? That we can engineer to release fast, slow, or slower. It's practically up to us to what ingredient we use to make MultiSal. So let me explain it. So let's say this is the MultiSal, and the polymer that we use is hydrating it. What does it mean? It goes into the top layer, the surface layer, and swelling. So then the outer layer swells, and this is how we get gradual release. So when you do product, for example, for body, exposing to the body, and you want it to release slowly, we use a polymer that will swell, compared to when you want it to release it faster, we use a polymer that undergoes erosion. You see it breaks down. You see this lines here? It totally breaks down, so the whole particle breaks down immediately. And when it breaks down immediately, you get fast release. So this is how we can control. It's in our hands what polymer we use to make the shell. That's it. The shell is our decision. And we have a variety of polymers. I'll come back to this, and we can decide fast or slow. So this is the story about the mechanism. How we manufacture it. So the process by which we manufacturing called spray dry. We are not, our company is not innovating manufacturing equipment. We are innovating the formula, the process of making it by combining the right ingredients into the right process. This is our innovation. So what we do, we make a suspension first, and then we spray dry it. So what you see here is the spray dryer. So this is the major spray dryer unit. Then you see there is a kind of pipes connecting to a cyclone. This structure is called the cyclone. Particles supposed to be falling down into the connector, the connection here. Here we combine everything that falls down. However, there are tiny particles, and these tiny particles can continue to flow and go into the dust collector. Typically, this is considered by us garbage. So what's happening here is a spray dryer head. What does it mean? Simple words. It means we spray a water-based suspension under a high pressure together with hot air. Hot air. So the hot air and the pressure of the nozzle cause the water to evaporate. And what left is the solid that were in the suspension, now extracted and falling down at the cyclone level. So this is kind of insides of what's happening. Okay, you see now the cross section of the process. Here is the spray drying starts. This one has two heads. We have only one head, but the big one is two heads. And you see how the powders, it's drying here. Actually, it's only drying here. And then because of the airflow, it will flow in this circle. And at the cyclone here, we collect it. This is the basic process of making. So what are the conditions? I'm telling you, I don't know if you will remember it. Maybe Jack has to remember it because he's going to control this, but important to control the outlet temperature, the temperature by which we collect, the inlet, the temperature that goes in. Look at this, you see that the evaporation of water is 100. We are using a higher temperature than the evaporation. We force high heat, but we lose the heat because the heat is drying out the water. Typically the load that we are looking for in MultiSal, the load of the ingredient, functional ingredient, is between 20 to 40%. The level of solid in the emulsion is about 30 to 50%. And I'll show you the formula in a minute. The viscosity should be below 200 CP, which means it has to be liquidy. And the emulsion drop size should be about 1 micron. The rest is less important for you now. Then this is typical formula. If you need to formulate a MultiSal, that's what you should pay attention. The functional ingredient, like menthol, retinol, whatever it is, should be up to 30%. In some cases, we can increase to 40%. It's possible to do 40%, okay? But we don't want to go because the higher we go, the faster the release rate. So we lose the effect of slow release. The shell should be anywhere between 50 to 80%. We use wax, 1 to 5%. This is the salt sphere component, and a surfactant, which is another part of salt sphere component, between 1 and 5%. This is example, not all formulas following the same process. Now, if you understand the formula, and I'm telling you the shell, so what is the shell? And how do you choose the right shell? The typical shell that we use is a carbohydrate, polysaccharides. It's based on starch. So you see, what is starch? Starch is a polymer of sugar, glucose. Now, we have straight, linear, which we call amylose, and we have branch that called amylopectin, okay? So of course, we have both and they are all mixed. However, another sugar polymer is cellulose. You see, cellulose is cross-linked in a much dense way. Cellulose cannot be spray dried easily, but starches can be. Now, you see that it has a lot of hydroxyl groups. These hydroxyl groups can be modified. Okay, so what are the modified? And we use the modified one. See, this is again the sugar groups. You see how they are connected. If we immerse them in a basic with NaOH solution, we can connect, we can replace, you see the OH with R, with a free radical, and the R is a octinyl succinate. Why octinyl succinate? Because it's a commercial product available, and octinyl succinate make the starch more suspendable in water and more compatible with the waxes. So we can increase the efficiency of the encapsulation. So this is one type of modification, but there are others. But this is the one that we're focusing on because we find that this gives the best results. Now, there are, you see every glucose molecule have potentially 1, 2, 3 R's to replacement, right? Replacement of the H. So we don't have anything that is completely replaced, but we have 1, 2, 3%. And these are the differences between the different starch, the degree of modification. Now, this octinyl succinate is approved for food and it's biodegradable, so that's why we like it so much. So what do we get? You see here the structure of the starch and the octinyl succinyl group that makes it, you see the long lipid, the long structure makes it more complex than the hydrophobic molecules that we're trying to incorporate. That's it. This is the basic modification that we have. But we have more type of materials for encapsulation, and I briefly tell you here. So first of all, we have the native, the raw starch. Then raw starch cannot be used by itself. It has to be hydrolyzed. There are multiple ways to hydrolyze. For example, cook them. So this is also hydrolyzed, okay? But the commercial product is called capsule. It's typically brown and we don't like it. Brown, it means it's oxidized already. So some food product, it's okay. For us in the cosmetic, we like to use white powder. So capsule has some benefit because of natural, but the color is a big issue. The other group is zinc. It's a modified starch by Grain Processing Corporation, GPC. And this is available at high viscosity, which is good for emulsification. It's very soluble at room temperature, and this is the big thing. We don't need to heat it up to solubilize it. Okay, and it has a low hygroscopy, which means it doesn't absorb a lot of water, so it can be stable and give us long-lasting release. So this is this. The third one is octyl succinate. This is the one that we use the most, which is called high cap. We have high cap 100 and high cap 200. It could be made either from corn, most of this is corn, or cassava, or other sources of starches. It's the best emulsifying capacity, okay? And this is the one that we use the most, but you see there are others. So you can now make a decision which one you want to use. If the product has to be natural, you will go to capsule. If you're looking for high viscosity, you may look into the modified starches by grain processing. If you want high emulsification, in other words, you want high loading. So these are the three based on molecular weight starches. Okay, so another group are the hydrolyzed starches, which are called maltodextrin. Maltodextrin or maltodextrin. The difference between dextrin and glucose is the number of carbon in the chain. In glucose, we have 6 carbon. In dex, we have 5. So it's a different structure. But never mind. It's a good material as well, but it's not as emulsifiable as high cap. So we can use it many times as an additive to the high cap, but not much. Then we have the multrin, tapioca starch. This is for people that don't want to have genetically modified structure. So this would be, multrin would be a good solution for this. The whole multrin is produced under an enzyme and no chemical reaction. So this is the multrin. Now, totally different are gamma arabic. It's coming from a different plant. It's the most expensive one, and it's sensitive to heat and water. So we don't like to use gamma arabic. Rice starch is another one. This is breaking down very slowly. Remember, I told you the two mechanisms, erosion and swelling. This is good for swelling. The starches, the multrin, are degrading, erosion, the mechanism that controls it, erosion. Unless we do something to restrict the erosion. So this is all about how to choose the starch. So if you need to formulate, you need to know what is the requirements, and based on this, you use this table to choose the right material to formulate a MultiSal, okay? And this is about the MultiSal, and I hope you will remember this concept and the principle behind it. Now we go on and ask the question, so what kind of product one can make with this? So you see a variety of product that using MultiSal. First of all, the stick. You see here a stick, this is a head-on, and now it's not so common. Years ago, it was very popular, but lipstick is another one. All the body sticks. We want to go into this business. Then makeup, they're all powder. We can take cosmetic ingredients that are liquid, MultiSal them, so we become powder, and then they can mix with other powders and can be used in makeup cosmetics. All the lip care, of course, this one and this are the same. Ladies' Spit Stick is full of Salvona technologies. The way the fragrance is encapsulated is MultiSal. This was the first commercial success of MultiSal in the world. Okay, now body powder, we make a ton of this with menthol, with other fragrances as well. And you see other stick, the other kind of deodorant stick, other powders. Dry shampoo is another one. Dry shampoo, for example, dry shampoo, if you want the hair to be dry, we have a technology, it's called MultiSal mattifying. It's absorbing the oil, so it doesn't make the hair so heavy. So people don't need to shampoo every day. What's wrong with shampooing? If you don't color your hair, it's fine. But if you color the hair, you know, the shampoo is basically diluting the color. And then you need to spend more money and more time on coloring more frequently. So dry shampoo has a value in this way. And other kind of product. And of course, soap bars. Bar cannot handle liquid ingredients and cannot handle acid. Our major business for Estée Lauder is encapsulating salicylic acid. Why it's not compatible? Because the bar is base, alkaline, and you cannot incorporate acid and base without a reaction. By isolating the acid, encapsulating it, now we can incorporate it into the soap and it's stable. And then when you wash, the water will activate and release the salicylic acid. So this is to get you a little bit understand what can you go, where can you go? This is not all. You see some more issues. For example, the Clinique bar. You know, the typical bar cost about $1. This is cost $16. Why? Because it's special, unique feature. What is the unique feature? We take a simple bar and make it into medicated bar. This is value added. That's what we are working on. How to increase the value. Making it value added increase significantly from $1 to $16. Okay, you see other medicated dandruff soap, again with salicylic acid. That's why MultiSal salicylic acid and we have other multisals are so popular. This is another one here. Antifungal, okay? Antifungal actives are incorporated and so on. Antibacterial, like BKC, MultiSal BKC can easily go into this product and give us the antibacterial benefits. More products that are not washed, you see here. This is a foot care powder in Chinese. You see the corn stick. We can use, I don't know who is formulating now sticks, but who is formulating sticks? Brian, who is formulating sticks?
I'm not sure about right now.
Alicia, right? Alicia, you are not formulating sticks. Not now. Okay, somebody in the team is formulating sticks. And you know that in the new place we have machinery to make sticks. And you look at this, this is not ours. Corn stick. What does it mean? Salicylic acid into the stick. And this is medicated stick. Okay, here is a wart stick, the same salicylic acid. The same one is working for this claim and for that another claim, okay? This is another oxy brand using our MultiSal salicylic acid. And it says here, fight acne 300% longer because of the technology. And of course, together with Thailand, we make a lot of color cosmetics with MultiSal salicylic acid for acne-prone skin. Okay, so I hope it gets you some ideas of what we could do, with these technologies. Of course, there are many more. Now, how do you know it's stable? You don't ask me, so I ask myself. How do you know? Here is a picture. We put the product into the MultiSal into the stick or into the soap, and it goes through the process. The process of making soap is the most difficult because there is heat involved, pressure of the extrusion, and then molding it. It's again a pressure step. So all these steps could destroy the MultiSal, but they don't. So you see, you can see very nice spheres at the end of the process. So MultiSal cannot be distracted by pressure, cannot be distracted by heat. You see that this molecule can only be activated with water. Now I want to take you, this is the basic structure of MultiSal, but not all MultiSal are the same. Dry sal is a version of MultiSal. It's again taking the active and encapsulating it and then coating it. So there are multi-steps as usual, but we get the same structure, but through a different process. Why do we need a different process? And what conditions this process has, and what product we could use to produce through dry sal. So what is the problem with the regular MultiSal production on spray dryer is, first of all, mixing with water. Water can expose ingredients to get oxidized immediately. Number one. Number two, the heat. Some ingredient cannot tolerate the heat. So whenever you need to encapsulate, you want at the end a powder, you need to think, can it survive the water? Can it survive the heat? If it cannot survive, we still can make it, but not in the traditional process. We have to use dry sal, okay? So what is dry sal? Dry sal is based on the V-shaped blender. I don't know if you saw it in the production, V-shaped blender. So the blender involves what? Involves, first of all, mixing, thorough mixing, and spraying at the same time. So this is all happening at room temperature and without any solvent. Now, this is a process that we didn't patent it yet. We will. Right now, we have only one product that's using this, and this is MultiSal Retinol. Okay, MultiSal Retinol. Again, we start with a particle that's very, very porous, very porous. So we have a special silica, a very porous silica. Okay, you see a lot of air. The thing is very dusty, very easy to float. So what's happening with this? We start with this process. We spray on the functional ingredients. So now it's all absorbed inside the particles. And at the end, we coat it with another layer of spray. And this is how we get the MultiSal, or the spray, or the dry sal. See, it's not exactly, but at the end, we get into a powder that encapsulates the functional ingredients without destroying it through the process. This is called dry sal technology. And right now, as you can see, works with MultiSal retinol. So retinol, you see the retinol, when it's encapsulated, it's much whiter compared to the free, which is yellow. So this is a way to mask color, mask odor by encapsulation. If you use retinol as is, some people get extremely irritated face. That's why we need to encapsulate retinol. So we can regulate the release. The same dose, the same amount, but if it's releasing slowly, the skin can buffer it, can accommodate it. But if it's released all at once, okay, and that's what most of the people do, release it more all at once, you get the inflammation, the irritation on the face. So this is retinol, and this is the difference between traditional MultiSal and dry sal. You see, I started with the hollow porous shells, load them with the functional ingredients, and then coat them. And this is how we get the MultiSal. Now, so this is the second one, right? The first one was the menthol. The second one I showed you was retinol. Now I'll show you the third version to see the variety that we can make. And maybe there are more, but this time we focus on these four. So this is a flavor cooling technology. What does it mean? This is a structure of the MultiSal. Inside you see the different sal sphere and the shell, okay? The core has ingredients that contribute the cooling sensation. The shell is a flavor, okay? When you put it on your lips, expose it to water, lips is an example, what's happening? The water will break down the shell, so you get a lot of the flavor coming out from the shell. You add more water, then you break it totally, and then the cooling ingredients come out. And then you have the cooling. Now, you can expand it. I mean, up to your imagination. You can use apple outside and maybe a chocolate inside. And this is where creativity comes in, because we encapsulate different flavors. They are in one, but in different compartment. And this is the point, compartmentalization or something like that. Okay, so this is flavor cooling technology. And it's very useful in, for example, lip balm. Okay, so you can see here, and this is the third one, but this flavor cooling, I hope you got the idea what you can do with this. Now I want to show you the third one, which is similar but different. This is for skin cosmetic, and this is a big product for us that's called MultiSal Multilayer. The multilayer means it's penetrating to different layers of the skin. But it also means that you have layers in the capsule itself. So you have the core and the shell. In the shell, we encapsulate typically acids. The acid help to exfoliate. And once you exfoliate the skin, then you can enhance the penetration, because the top layer are typically very resistant to penetration. They are dead skin full of proteins that prevent the penetration. So the shell is encapsulated with, in this case, alpha-hydroxy acid, and that what helps to exfoliate the skin, and it also helps to moisturize, to retain water. Why it's so important? Because only when the cells are fully hydrated, they can absorb the ingredients and respond to the ingredients. Then inside, we have two types of salt sphere. You look at the picture, you see we have smaller and bigger particles. The smaller naturally can penetrate deeper than the larger. And we use it to penetrate to different layers of the skin. So for example, if we want to get to the dermis, we need to go with a smaller particle. If we want just to get to the top layer, we can manage with a larger particle. So it depends what we want to do. In this case, the smaller particles contains collagen boosting peptides. So these peptides are boosting the synthesis of collagen elastin to reduce wrinkle appearance. The larger one are working on the color, which means brightening the skin, okay? So this is the technology. You see here how it works. You have the particle as is, the multi-layer, MultiSal multi-layer. These are the particles as there is. There is a little bit of a break when you rub it with the water, then the shell gradually will break down. It will take an hour or two until all the acid is released. Now, there is another value of separating the release. Acid typically will reduce the pH for a time. Now, the whitening agent that we use here cannot operate at a low pH. The optimal operation pH for the whitening is actually higher pH, like 6.5, 7. So if we put them and release them together without encapsulation, we counteract. No good. No good. We counteract. We don't get the results. So by delaying the release in a consecutive way from different compartments, at different time, at different location, we are able to see. You see here a cross-section of the skin after an hour, half an hour, an hour. You see that the small go deeper into the dermis. The larger particles will stay on the top and will help us to brighten the skin. How do we know this works like this? We can actually measure the particle size in the lab. You know how to do it now. So we have the smaller particles with the peptides. They are much smaller, about 0.5. And then we have the brightening agent, which is a particle of about 2 microns. So this is how we design it to penetrate to different layers and cause the effect. And you can see a short video that will explain you what's actually happening. And we use this video to explain to our customers what is the value of using MultiSal. And you see here, it's called triple action anti-aging. It's the same.
MultiSal triple action anti-aging
is the same as a multi-layer, but multi-layer we call it for China, and the triple action was made for the Beachbody brand, and the Beachbody brand uses this name. Just they wanted to have their own name, so here it is for them.
A multifunctional platform designed to deliver several functional ingredients to the skin. Triple action anti-aging exfoliates, moisturizes, reduces the appearance of age or sunspots at the skin surface, and reduces the appearance of fine lines and wrinkles. When the MultiSal microsphere is applied to the skin, the friction of application opens the outer microsphere, resulting in the release of lactic acid. The lactic acid acts to not only exfoliate the stratum corneum, but to induce osmotic swelling in the cells underneath. This increases the moisture content of the skin. The slow release of the actives from these spheres prevents the pH-induced irritation traditionally associated with hydroxy acids. The interior of the microsphere contains 2 different types of submicron spheres. The smaller spheres in blue containing collagen boosting peptides, as well as the larger spheres in purple, which contain phenylethylresorcinol. The larger spheres cannot penetrate as deeply as the smaller submicron spheres and begin to release the phenylethylresorcinol inside the epidermis, where it can reach the melanocyte. Acting at the melanocyte, the phenylethylresorcinol reduces the appearance of melanin, whether from age spots, sunspots, or other environmental factors, brightening the skin's appearance. As they continue to penetrate further, the submicron spheres containing the collagen-boosting peptides are able to reach the dermis, where they release the peptides to boost collagen production. The subsequent increase in collagen production firms and lifts the skin, reducing the outward appearance of fine lines and wrinkles at the skin's surface. The combined effect is for moisturized, exfoliated, brightened, wrinkle-free skin, which returns to the skin its appearance of youth.
Wonderful. I hope you
MultiSal.
understand. I hope you understand. And I also hope that it's not only me saying that incredible technology. Here you see a Java mask. It's a #1 product in Thailand for many years now. And you see how they explain it to their customers, the 3 ingredients that we have encapsulated, and how it goes into the multi-layer of the skin. This product then moved on to China, and it became a big seller also for us and also for the company. It's called Java Mask. So it's really incredible technology in the way it works. Then the other major brand, it's called Derm Exclusive. And Derm Exclusive use this technology for a whole range of product. Okay, and you see the effect. Okay, so it's not just I'm saying it's incredible. You see the effect with day 1 and after 30 days. I will ask you later on to tell me if you recognize the person. You see around the eye. So there are multiple applications. Do you recognize the person? You don't. So you see the wrinkles in the forehead, and after 30 days, around the lips, around this, you can see the wrinkles disappears, the smile lines. So overall, it's a fantastic. This is the person. Do you know this person? Did you hear about Minnie Minor, the actor? You don't know. Okay, it's a British actor. She lives in California, and we did together a program for the TV. Sometimes if we check it, if you cannot sleep, she will present. She was the representative of this product, and she tested it and showed on herself what is the effect of this. Anyway, this is the technology that's called MultiSal Multilayer. And formulation is very easy when you go to powder. Alicia, you did a wonderful job with different powders. Anhydrous, we can use it in lip, in silicones, in oils. Massage oils, for example, are using MultiSal fragrance or MultiSal menthol for cooling and refreshing. Then it's possible to use also in aqueous bases. Depends on how much water you have. Toothpaste has a good amount of water, but it has, the water is bound to the silica, so it's not considered to be active water. So therefore we can use it for this solution. And typically when you make a lotion, any kind of lotion with water, we always would recommend first incorporate into the oil phase and then take the oil phase into the rest of the formula. Okay, I don't want to take your time more. I hope, first of all, you know now what is characteristic to MultiSal, the structure, the core, and the shell. You now know the mechanism of release. It could be activated by water and then slow release, or erosion, which is immediate release. And you can control it, but it depends on what formula, what polymers you're going to use in order to make the MultiSal. So you're able now to determine how MultiSal would fit into your application. So if it's anhydrous or water-based, you can make a decision whether it will work or not. A MultiSal Sal Cool, for example, works miracles in water-based. It's not breaking down. And when you put it on your skin, you feel the cooling, but anyway, you don't smell anything. Flavor cooling is ideal for only anhydrous product. You know now the principles of formulating MultiSal. I showed you the ratios. So this is the big picture. Of course, each one of them is slightly different, but the principle is there. And you also now know the difference between dry sal and traditional MultiSal. From point of view of our customer, it's all MultiSal. But internally, we want to separate what machinery we are using. So we call it either MultiSal or dry sal, so it's clear to everybody what we are doing. And we went through at least 4 MultiSals. MultiSal Menthol is a big product. Mostly we produce it for Indian market, for body powder, very powerful. The same goes with MultiSal Wintergreen, which is methyl salicylate for the same market, and MultiSal fragrances for the same market. We don't do a lot of flavors. We are not so much catering for the food or ice cream. It works, by the way, MultiSal works miracles in ice cream, because in ice cream, the water is bound. It's not active to dissolve the MultiSal, the water. Then MultiSal Retinol, it's a big item for us and it's growing, especially in China. MultiSal Flavor Cooling, it's another technology for lip balm, among other things that would work for lip balm. And of course, MultiSal Multilayer, which combine multiple functionalities. We many times don't explain too much about this, but you understand that you cannot formulate a stable formula with acid and also with peptides. The peptides will denaturate because of the acid. And some of the brightening ingredients require a higher pH than the acid can offer. So there is no way to put them all together. The only way to do it is to encapsulate them and then put them in different compartments into one single ingredient.